Let's see a little bit of trig in this. No, this is a classic one. This is just, it's classic. It's a little funky. We're going to use the Pythagorean Theorem. We're going to talk about circles. Here it comes. Same instructions. We want to sketch the curve and show like what direction it's moving. Well, we also want to eliminate the parameter and write the resulting rectangular equation. And then we're going to adjust the domain of the rectangular equation if needed. Sometimes you don't need to. Like I was looking at your homework, a lot of times it's just fine. Not an issue at all. And what we're going to mess around with is x is equal to 3 times cosine of t, and y is equal to 3 times sine of t. All right. Here we go. Here we go, and here's the weird. Again, I like to eliminate the parameter first. Just my thing. And again, you might just want to make a frickin' table here. Just start plugging in values of t. I'd start with 0, then maybe go to pi over 2, then maybe go to pi, then go to 3 pi over 2. Go back to 2 pi and just see what's up. But I don't like to do it that way. I don't like to do it that way. That's tedious. Remember back in the day, do you want to graph every parabola with a frickin' table? Or do you want to just know what a parabola looks like and learn how to do some transformations? So, well, we're not going to be able to solve for t here very easily. But there's a little trick. So let's just solve for cosine of t and let's solve for sine of t real quick. So we're just going to divide by 3 and divide by 3. Divide by 3 and divide by 3. So we're just going to say, all right, cool. X over 3 is equal to cosine of t. And y over 3 is equal to sine of t. Now here's the weird. Here's the weird. We're going to make up an equation that we can plug both of those things in so we can tie it all together. What equation has a cosine and a sine? And we could say that there's something it's equal to. What is it? Is there any formula that has a cosine and a sine in it? Called the Pythagorean Theorem or anything like that? Isn't sine squared plus cosine squared equal to 1 as long as you have the same variable that's inside of there? Yeah. Yeah, it is. Yeah, it is. So what we could actually do is just take this and go, bruh, do it. Don't put in cosine of t, put in x over 3. Don't put in sine of t, put y over 3. Oh shit, everything's into x's and y's now. We just did it, but it's by using this frickin' trick. You gotta use the Pythagorean Theorem. So when you see the sines and the cosines and this parametric equations, think sine squared plus cosine squared is equal to 1. Plug that crap in, do a little bit of algebra, and we see what pops out. Now what's about to pop out is a circle. It's a circle. I need you to be able to recognize the form of a circle. It's going to come back in polar. The next section we're about to mess with. So once we square it up, we get y squared over 9 plus x squared over 9 is equal to 1. Well, we jumped over a little bit of our some conics and such. We're not going to talk too much on this, but if we multiply both sides of this thing by 9, right, this goes cancel, cancel, cancel. And then we bring this in, and I'm going to turn the x's and the y's around. I'm just going to say x squared plus y squared is equal to 9. That's a circle with a radius of 3, in case you don't know. A circle centered at the origin. Oh, by the way, have you ever seen this? You ever seen that? That's called the unit circle. That's the unit circle. But that's the general form of a circle, centered at the origin. Centered at the origin, where r is the radius. Come on. So we'd say for us, oh shoot, our radius is equal to 3. So we've created a rectangular equation. That was that second part. And we got a little bit of information to help us graph it. It's a circle with a radius of 3. I think we can knock this one out. You know what I mean? You know what I mean? Think we can knock this one out, maybe get this thing a little bit of a graph? Let's just do this. Let's make I'm gonna make a shitty circle. That's pretty nice, huh? Oh, I got technology. What the hell? I might as well just make a circle that look or an oval or whatever. Do you believe me it's a circle or an egg? Gosh dang, that's horrible. I can't do that. I can't do that. That's just so bad. You know what I mean? Let me try that one more time. Let me try and make it so it looks something like a circle. Ah, that looks more like a circle, not like an egg. So there we go. We say the radius is 3. So these points, you know what I mean? Oops. Make a bigger dot when you miss. And there's our x's and our y's. Okay. Whew. Dude, we did it. We did it. We've graphed it. Haven't we? Shit. We got to plug in values. We got to know which direction it's going. Is it going clockwise or is it going counterclockwise? So we had the x was equal to 3 times cosine of t, and y was equal to 3 times sine of t. I just plug in values of t, see where you start. Plug in 2 values. The values I would choose was t is equal to 0 and t is equal to pi over 2. I want to keep my life as easy as possible. I'm going to be writing some terrible crap. So we get 3 times cosine of 0. What's cosine of 0? That's 1. And then we plug it in over here. So 3 times sine of 0. What's sine of 0? 0. So we get 3 comma 0. Well, that's a big xy I made there. Huh? So we got a point. So it's saying we're going to start right here. And let's plug in pi over 2 and see where we go. So 3 times cosine of pi over 2. That's 0. And then 3 times sine of pi over 2. That's 3 times 1. So we get 0 comma. Oh. There it is. So we must be moving in this direction. So it's telling us that's our orientation. Cool. So we did part 1 and we did part 2. We're really happy with ourselves. We got this. We got this. And then it asked us, adjust the domain of the rectangular equation. Is there any domain restrictions? And x squared plus y squared equals 9. Is there some value of x you're not allowed to plug in? No. Do circles? If we do this, will you just keep going around and around and around and around and around and around and around? Yeah. There's no domain restriction. There's no issue. There's no problem. There's nothing to adjust. There's no denominator with a variable in it. There's no square root function. There's no logarithms. There's no tangents. So there's no problem. We graphed it up. But this is a classic. You see something start off like this. X is equal to 3 cosine, or y is equal to some sine of something. You were thinking the Pythagorean frickin' theorem. You got to plug it in, do that solve for cosine, solve for sine, plug it in, dick around with it. Typically makes a circle. Sometimes it makes a ellipse, but we didn't do much talking about that, so we're going to jump past it. Hopefully you learn a little bit about that in your college algebra class. So that's kind of the game. The next ones we're going to start messing around with. Maybe I'll put a tougher one in there, maybe a little more algebraically dense, but we're going to get into what's called projectile motion. It's one of my favorite things. It's one of the simpler things we do in physics, if you got a good working knowledge of the trigonometry. So, I don't know. We'll see what happens. Later.